Hello everyone. In this short video, we're going to look at the calculation of soil bearing pressures in S foundation and also the influence that overburden pressure can have on these calculations. So for this example, I have a rectangular footing with a 700 kilonewton load applied at the top of the pedestal. And I have a one layer soil profile defined. So if I go to the define menu and I go to soil profiles, I can see this one layer soil profile. And underneath this setting, I have an ultimate bearing capacity of 600 kPa. Now the ultimate bearing capacity is defined by the user in S Foundation to essentially describe the maximum capacity of the ground springs, nonlinear ground springs, underneath our foundations. But it is actually also used to calculate our allowable bearing capacity used for design checks. So here, we can see that we have this 600 kPa ultimate bearing capacity, but to the right of this dialog here, I have within the design input window, factors of safety defined. And I have a factor of safety for bearing capacity of 3 defined. So my allowable bearing capacity would be my ultimate bearing capacity divided by the bearing capacity factor of safety of 3, so it would be 200 kPa. So let's just keep that number in the back of our head. So what I'm going to do now is I'm going to go ahead and also introduce the loads that are applied. We talked a little bit about it already, but I'm going to go to the design load cases, and here you can see that I have load cases, one load case defined with a 700 kilonewton axial load on my column. And I'm also considering some substructure load factors as well. So I'm considering self-weights, soil, buoyancy, and any surcharge loadings that might exist. I'm going to play around with some of these settings, as you'll see later on. But this basically allows us to consider the soil on top of our foundation and other aspects related to that. So let me just click OK. And I'm going to start by running the analysis for this setting. So click on Analyze Code Check, click Yes to run the analysis, and we're running a nonlinear analysis. I don't need to worry about the soil sediment checks here, but what I'm getting is basically my soil bearing utilizations. And I can actually look at this in a more numerical format here. If I look at the design output window, I'll just make this screen a little bit larger. Here I can see that I've just chosen to run a few of my geotechnical checks for flexible and rigid analysis. And my soil bearing code checks are the highest utilization of those sets. We have similar but not identical demands because they are using different approaches to calculate those demands. Sometimes they won't line up exactly. And here we can see our capacity. So this is our soil bearing capacity of 226, almost 227 kPa. So you may be wondering, well, what happened to that allowable soil bearing capacity that you said was going to be 200 kPa? Well, we can actually drill down into these details here. If I just left click on the details of that footing's results, and specifically I want to look at the capacity. Here I can see the ultimate bearing capacity, 600 kPa. I can see my factor of safety and the net allowable bearing capacity as well, or bearing pressure rather, 200 kPa. But then I have this overburden pressure, and that's 26.478, so that's where that additional capacity is coming from. So the way I like to think of it, and it was described in the help system as well, is that if we excavate the soil for our foundations, we're going to remove a volume of soil that we know the soil at this layer, to which we've excavated to, was capable of supporting. So then we add this overburden pressure, that weight of soil basically, from the removed soil to the total capacity. Hence why we have an increase in capacity. But if you were expecting to have a allowable bearing capacity of 200 kPa, you may not necessarily want this. And it's possible to ignore that as well. If we go to the define menu, and here I go back to my design load cases, I can ignore that by toggling off the soil substructure load factor. When I click OK, I run the analysis and code check, and my capacity will be different, although my utilizations tend to be similar in this example. But we'll notice here that the capacity is 200 kPa. So I look here at the utilizations again, or sorry, the overall capacity, and I can see that the overburden pressure in this situation is 0. One thing to note is that when we are ignoring soil, we're also ignoring the weight of the soil above our foundations. So if that wasn't your intention, you may want to consider that using some other load type rather than the automated way that happens when we account for the soil with that checkbox. So hopefully this is enlightening to you. If you'd like more information on Nest Foundation, we do have plenty of other videos and also training course available. So please feel free to check that out.